Okay, now in this video, we want to look at the number 4 question. So we see that we have the logarithm of 3x plus 1 to base 6 is equal to the logarithm of 3x minus 1 to base root 6. So this is 6 and this is root 6. You know, the bases are not the same. So how do we go ahead and solve this? Well, I'm going to just make use of the change of base of logarithms, and I'm going to apply that here, right? I want it to affect this one. Okay. So by the change of base of logarithms, I am going to change the base to base 6 on the right hand side. So this is by making it a fraction, okay? When we did it to the number 3, we made to the new base. So I'm going to make the new base to be 6. So I'm going to rewrite the right hand side as a fraction. So this will be 8. This is, I'm going to rewrite as the logarithm of, now, I change the base to base 6, and I'll put down the denominator, the logarithm, and I'll put down the base 6. So this is what I will change it to, right? The basis. Okay, so what I will do here is to put down the function here, 3x minus 1. Okay, the expression 3x minus 1. And then this part, I'm going to put down the other base, the older base. So put down the square root of 6 like that, right? Okay. Now you observe that square root of 6 is the same thing as 6 raised to the power of 1 over 2. Right? So in place of square root of 6, I would like to put 6 raised to the power of 1 over 2. So put down 6 raised to the power of 1 over 2. And you know that 6 raised to the power of 1 over 2, that since this is just a power, I can move it to this place as a constant product, okay? So I'm going to move the power 1 over 2 to this point, alright? Okay. So that is it. And you know that logarithm of 6 to base 6 is 1. In fact, we are just going to do a whole calculations here. So the logarithm of 6 to base 6 is 1. So I'm going to clean it up again. And I'll put it down 1. And 1 over 2 times 1 is just 1 over 2. Right? So this is 1 over 2. Well, I don't like a fraction in the bottom. So what I would like to do again is to multiply the top and the bottom by 2. Because I know that if I multiply 2 to 1 over 2, I'm going to have 1 in the denominator. So that clears the denominator, right? So I'll just go ahead and multiply this with 2. And I will also multiply the numerator with 2. So that 2 divided by 2, they will just cancel out, alright? So that means you're going to have 2 times 1 over 2. In fact, the denominator now becomes 1. And we are okay with it now. That was... Okay. So that is for the right hand side. Now for the left hand side, we are just going to have the same thing. Let me just bring it down. Logarithm of 3x plus 1, right, to base 6, like that, right? Okay, very nice. Now, well, I have seen that the bases are the same, alright? It's just that this has a constant multiple, which is just 2. So I would like to take it up. So I would like to move these 2 up to this point. So I'm going to put down the 2 here, cleaning it from this position. Okay, that is what we do usually. So from here, I will see that I'm going to have, let me just clean this arrow and put the 2 properly. So we're just going to have the 2 over here. Now, since both sides have the same basis, okay, so we are just going to equate these entries. So that means that 3x plus 1 on the left hand side is equal to, let's expand that. So maybe let me just do the elementary expansion for you guys to see. This is it. Put down the squared and we put it down 2 times, alright? 3x minus 1. So 3x minus 1 times 3x minus 1. Okay, so what we do is to go ahead and, let's say, multiply this with this one, multiply it with this one, okay? And then we go ahead with the x. We use this negative 1 and multiply with the first one. We use this negative 1 and multiply with the last one. So 3x times 3x, that's going to be 9x squared. So I'm going to go ahead, 3x times negative 1, that's negative 3x, right? Negative 3x. Again, negative 1 times 3x, that will be, again, negative 3x. And then, negative 1 times negative 1, that will just be positive 1. Okay, so on the left hand side we just have 3x plus 1. So I have already seen that this is going to give us a quadratic, in fact this is already a quadratic equation. So all we need to do is to try to simplify things a little bit, right? And then try to solve the quadratic equation for the two values of x. So here we see we are going to have negative 6x. Okay, since we're having negative 6x here, so this is 9x squared minus 6x plus 1. Then on the left hand side we still put down this. Okay, so let's say we move this one to the right hand side. That is by we subtract 3x from both sides, and we do the same thing with 1. So we are going to see that we have 9x squared minus 9x equals to 0. So we move this one over here, that will become negative 3x. So negative 6x minus 3x, that is negative 9x. Again, we move this one over here, that will become negative 1. Okay, so that's just by saying subtract 1 from both sides. So if you subtract 1 from both sides, that will be 0 here, and this point 0. So the 1 is nowhere to be found again because it has been cancelled with the other 1. Okay, so this is what we enter with. And from here, we see that if you factor something, okay, I can say let's factorize this. We're going to take out what is common, which is 9x. So 9x is here and 9x is here, though this one is x squared. So we're going to have 9x, and I'm going to bring in a bracket. Now, in this first position, we are only left with just a single x, alright? And in this second position, we are just left with a single 1 like that, and we equate it to 0. So you see that the product of two terms is giving you 0. In fact, at least one of them is 0. So if you have two numbers, so let's say two unknown numbers multiplying together to give you 0, you know, if one of those numbers is 0, then the whole thing will be 0. Otherwise, it's not possible in the set of real numbers. So that means that what I'm trying to say is that it's either this one is the 0 or this one is the 0, because the both of them contain an unknown, which is x. So maybe x must have been something that contains 0. Okay, so that means that it's either 9x is 0 or x minus 1 is 0. Okay, let's just continue here. If 9x is 0, if you divide both sides by 9, okay, we're going to see that for this one, we're going to see that x is 0, or now if x minus 1 is 0, if you add 1 to both sides, you will see that x is equal to 1. That is, try to move this one to this side to become a positive 1. So these are the two values of x for which that equation will be satisfied. Okay, so that's for the fourth question. Alright, that was quite fun, right? Okay, thanks for watching, and please subscribe to my channel. Let's move on to the number 5 question.